This Zoom session is being brought to you by the fractal Almond Octaves Z forming. All right, for today. All right, let's go to section 5.6. I see there is one section after this remaining. We are coming to the edge of the course, which is all well and good. All right. For today, vectors in space. Okay, I couldn't resist that. All right, so these are three-dimensional vectors with three components: x component, y component, and z component. They correspond to an arrow in three-dimensional space pointing from an initial point to a terminal point. The vector a by b by c is also called ai plus bj plus ck, where I is a vector in the x direction, j is a unit vector in the y direction, and k is a unit vector in the z direction. As before, a vector is a displacement from one point to another. From x1, y1, z1 to x2, y2, z2 is the vector x2 minus x1 times I plus y2 minus y1 times j plus z2 minus z1 times k. And its length is given to you by the Pythagorean theorem, the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And as in two-dimensional vectors, you add, subtract, and multiply by scalar component-wise. A by b by c plus d by e by f equals a plus d plus b plus e plus c plus f. So you add the x, y, and z components separately. A by b by c minus d by e by f equals a minus d by b minus e by c minus f. You subtract the three components separately. And a k, a number, a scalar, times a by b by c is ka by kb by kc. You scalar multiply per component. As in two-dimensional vectors, there's also a dot product. The dot product of v and w with length v, length w, an angle between them, theta. Their dot product can be given two ways. Just a second. Can go in two ways. It's a sum of products of components, v1 w1 plus v2 w2 plus v3 w3, and it also equals the length of v times the length of w times cosine of the angle between them. Therefore, we can solve for theta by cos theta equals v dot w divided by length v times length w. So take our cosine of that and get the angle between two vectors, just like with two-dimensional vectors. This dot product has many rules that resemble ordinary product for scalars. It's commutative. U dot v equals v dot u. Because each of these components is commutative. U dot v plus w is u dot v plus u dot w for similar reasons. So it's distributive. U dot u equals length of u squared. That follows from both of these pretty much directly. U dot u by u1 squared plus u2 squared equals u plus u3 squared. And therefore the length squared. Also, it's length of u times cosine of 0 degrees, which is length of u squared. And there's a zero vector with components 0 by 0 by 0, and its dot product with any vector v is 0. Now, if you take v and divide it by its length, it will have unit length 1. So this v over length of v is a unit vector in the v direction. Okay. Now, if you have a vector in three-dimensional space, and it's at an angle alpha from the x-axis and beta from the y-axis and gamma from the z-axis, then alpha is the arc cosine of length of v over length v dot I. Beta is arc cosine of v dot length dot j over length v, and gamma is arc cosine of v dot k over length of v. Basically, this will be the unit vector dot each of the direction vectors. And that angle arc cosine is the angle from each of the directions. Another way to put it is that length of V is a length of E times cos alpha by cos beta taught by cos gamma, this being the unit vector in the V direction, or in other words, this. So we can find some examples. Find the distance between two vectors, -1 by 2 by 3 and 0 by -2 by 1. Okay, the distance, well, I take the square root of the sum of squares of different components. -1 minus 0 squared plus 2 minus -2 squared plus 3 minus 1 squared. So this would be 1 squared is 1, 4 squared is 16, 2 squared is 4, root of 1 plus 16 plus 4 is root 21, and that's the length. Here they're asking for the length of I minus j plus k. What's its length? Well, I is 1, 0, 0. J is 0, 1, 0. K is 0, 0, 1. So we're looking at the length of 1 by minus 1 by 1. So its length is square root of sum of squares. 1 squared plus -1 squared plus 1 squared. After a very small amount of arithmetic, that's square root of 3. Next, let's start with two vectors. V is 3i minus 5j plus 2k. W is minus 2i plus 3j minus 2k. So V is 3 by -5 by 2. W is -2 by 3 by -2. So what's the length of the difference? And what's the difference of the lengths? A grammatical difference between them, but there will be a numerical one. Okay, V minus W, take the difference. 3 minus -2 by -5 minus 3 by 2 minus -2. So that'll be the length of 5 by -8 by 4. And the length of this will be square root of sum of squares. 5 squared is 25, -8 squared is 64, 4 squared is 16. Square root of their sum is square root of 105. That's the length of the difference vector. Now the difference of the lengths, well, length of 3 by -5 by 2 minus length of -2 by 3 by -2. For this, square root of sum of squares. Square root of 3 squared plus -5 squared plus 2 squared minus this. Square root of -2 squared plus 3 squared plus -2 squared. For a bit of arithmetic, that gets you root 38 minus root 17. Now, it should be fairly obvious that these are entirely different quantities. All right, here we have two vectors, 2 by 2 by -1, 1 by 1 by 1 by 2 by 3. What's their dot product and what's the angle between them? All right, the dot product is easy enough. 2 by 2 by -1 by dot 1 by 2 by 3. Take products of components. 2 times 1 is 2 plus 2 times 2 is 4 plus -1 times 3 is -3. 2 plus 4 minus 3 is 3, and that's the dot product. Now, angle is the arc cosine of the dot product divided by the product of the lengths. Length of 2 by 2 by -1 is root of 2 squared plus 2 squared plus 1 squared. Length of 1 by 2 by 3 is root of 1 squared plus 2 squared plus 3 squared. Okay, that's arc cosine of 3 over root 9 times root 14. And after a bit of work on the calculator, that gets you approximately 74.5 degrees. Okay, that's it for this right now.